Hey friends, welcome back to Civil Engineering Mastery. In this video, let's model and analyze G+4 commercial building in Staad.pro software. First, let me show you the geometry. This is the typical framing plan of the commercial building. Column size is 450 by 450 and beam size is 300 by 600. So let me show you the elevation. So here from ground level, it is 6 feet is the foundation depth, and above that it is 4 meter height, that is 13 feet 3 inches. Each floor is having 13 feet 3 inches height, and above that we'll be having 1 meter parallel. So this is the geometry of the G+4 commercial building. So let's model the same in Staad.pro software and analyze it. Let's start modeling the geometry. Go to geometry, click run structure wizard, and here you have to select frame models and double click on bay frame. So here you have to enter length, height, width and number of bays along length. We are having number of bays along length is 3 and number of bays along height is 6 including the foundation depth, and number of bays along width is also 3. So here we need to enter the total. So we are having 23.6 feet of each bay. So that is 7.16 meter multiplied by 3, which is 21.48. 21.48, and along width also the same 21.48, and along height we are having 4 meter each floor, so which comes 20 meter plus 1.68 is the foundation depth. So it is 21.68. Now we have to enter the each base value. So it is 7.16. Click OK, and here we have to enter it. First one is 1.68 and 4, and each one is 4, and then give apply. When you close this will ask you, would you like to transfer or merge this prototype into Staad.pro? Say yes. Give OK. So this is our geometry. Geometry has been created. So now let's start adding the secondary beams. We are having only main beam. We need to add secondary beams in all the level. Let's select the ground floor, and then we can add the secondary beams here. This is also 7.16 and this span is also 7.16. If we check in the geometry, so here we have secondary beam and one secondary beam like this, and this side also we have one secondary beam like this. So let's add the same in Staad software. So here you can select this one, Control C, Control V. It is in the Z direction minus 3.58. And again here also we can do, it is in the X direction, is negative 3.58. And again we can select this, do the same thing, negative 3.58. So now all the secondary beams have been added. First let's assign the support conditions. Select all the nodes, go to command, support specification, fixed support, add, give assign. So support is assigned now. Next let's add the member property. Go to member property, prismatic. So here add rectangle. We are having the column sizes 450 by 450. It is a square column. Add. We are having the beam size as 0.3 by 0.6. This is the size of the main beam, and secondary beam size is 0.2. It is 8 inches by 2 feet. Give add. Next let's add the plate thickness, which is 5 inches, 0.125 meter. Give add. Select beams parallel to Y and then give assign. Column properties have been assigned to all the columns. Next we need to assign the beam property for main beams. First select the plinth beam layout. So here all beams are main beams only. Go to select beams parallel to X and beams parallel to Z. You assign. All the main beam property has been assigned to plinth beam layout. Next let's go to ground floor. Select the ground floor layout. Here let's select all the main beams. Give assign. It is little bit time consuming if you go floor wise. So what you can do is you can first, instead of replicating all the floors, before that you can add the member properties and then replicate it, so that you don't need to go to each floor and then assign the properties. So all the main beam properties have been assigned. Next we have to assign the secondary beam property. So go to ground floor. As I told you before, instead of selecting each floor beams, if the geometry is symmetry, you can better assign the property to one floor and then you can replicate it, so that way you can speed up your modeling process. It is done. So we are done with assigning beam property and column property. Next, let's model the plates. To do so, first let's select the ground floor. Select 4 noded plates. You can add like this. See, now all the plates have been added. Before meshing the plates, we have to check the beam plate connectivity. Go to tools, check improperly connected plates. See, it is showing the improperly connected plates. So now what you have to do is you have to make it proper. So for that we need to add one more beam. Go to geometry, add beam, add T-beam by perpendicular intersection. So here we have to add one beam, and here also we have to add one beam. Similarly here, everywhere you have to do the same thing, because the beam plate connectivity is not proper. That will give you error if you analyze the model. So that is why I am adding the beam like this. And after making the proper plates, you can delete these unwanted beams. Only you can keep the original beams. See, it is like this. If you check the plate, see, it is like this. Now select all the plates and then delete it. So next what you have to do is just you have to add the plate like this. See, you can see the plate, and then you can do Ctrl C, Ctrl V, select this point, give OK, and then you can make a copy everywhere. See, now all the plates have been added. Before meshing the plates, let's select all the duplicate beams and then delete it. So these beams we don't want, delete. So this is our original geometry. So in this way we will be having the secondary beams. Now the plates are organized. So in this way we have to do the plate modeling, because it will be very helpful you to rectify the errors while analyzing the model. Just select all the plates and then you can do all together, because the meshing size is same for all the plates. There is no difference in meshing since the geometry is similar. Select generate plate mesh 3 3 3 3, give OK. See, the plate has been meshed. Here I am not going to replicate these plates to other floors, because I need to assign the member property and then I need to assign the loads. So since all the loads are similar apart from terrace floor, what I'm going to do is I'm going to assign the property first, and then I'm going to replicate to the last floor, the top floor, and then I'm going to add all the loads, and then I'm going to replicate to the typical floor, so that this will help me to reduce the modeling time. Let's assign the property first. Go to command, member property, prismatic. So we have already defined the plate thickness. Select the plate thickness and select all the plates and give assign. See, now plate thickness has been assigned. Translational repeat, give y direction. So the height is 16 meter. I'm going to add these plates to the top floor and give OK. So if you see, only ground floor and top floor are having plates. Now after that you can add the load, assign the loads, and then you can replicate to the typical floors, because always the terrace floor, the top floor loading will be different from the typical floor. So for that sake I have done like this. Before defining the load, let's look into the design data. Grade of concrete is M25, grade of steel is Fe500, wall thickness is 9 inches, floor height is 4 meter for each floor, safe bearing capacity of soil is 200 kilonewton per meter square. Depth of foundation below ground is 6 feet. Column size is 450 by 450. Beam size is 300 by 600 for main beam. For secondary beam, it is 200 by 600. Slab thickness is 125 mm. Next, let's coming to the loads. Dead load. First one is self-weight. Since we have added the plate elements in Staad.pro software, it will automatically calculate the self-weight of the slab. But still, we need to know how do we calculate the self-weight. So thickness multiplied by slab thickness multiplied by unit weight of RCC will get the self-weight of the slab, and wall load is 0.225 is the wall thickness, and 4 meter is the height of the floor, and 0.6 is the depth of the beam. So we can reduce that, and then that multiplied with the unit weight of brick. So we get 15.3 kilonewton per meter. Parapet wall load also we need to calculate similarly. The height of the parapet wall is 1 meter. So we get 4.5 kilonewton per meter. Floor finish load is 1 kilonewton per meter square. Waterproofing is 1 kilonewton per meter square. Live load 4 kilonewton per meter square for typical floors, and for roof it is 1.5 kilonewton per meter square. Let's see few data for seismic load. Location is Bhopal, zone 2. And soil type is medium. Importance factor is 1.2. Response reduction factor is 3. These data I will show you in the IS 1893 code while defining the seismic load. First, we have to define the seismic definitions. Give add. So here you need to select the Indian code IS 1893 2002. You can even enter the values, or else you can give generate. So this window will appear. Here you have to select the zone. This zone 2. For that value is 0.1. Next we need to enter the response reduction factor value, importance factor. So let's see in the code. See the seismic zone factor. For zone 2 it is 0.1. In table 8 importance factor is there. So residential or commercial building other than those listed in serial number 1 which occupancy more than 200%, for that we have to consider 1.2 importance factor as 1.2. Next, let's see the response reduction factor that is given in table 9. So response reduction factor for RC buildings with ordinary moment resisting frame. There is a note here. So let's read that. RC and steel structures in seismic zones 3, 4 and 5 shall be designed to be ductile. Hence, this system is not allowed in this seismic zone. That means this ordinary moment resisting frame is not applicable for zone 3, zone 4 and zone 5. Only it is applicable for zone 2. So in our case we are having zone 2 only. So we can consider this only ordinary moment resisting frame. So response reduction value we can consider as 3. Damping ratio. The value of damping shall be taken as 5%. So let's enter all the values here. First here you have to select the ordinary moment resisting frame. OMRF. So for that value is 3, and here in importance factor we are having only important building and general building. If you click important building it will update the value as 1.5, and if you click general building it will take the value as 1, but in our case we have to consider 1.2. This is because IS 1893 2016 code is not updated in this version of Staad.pro, so that is why it is showing only one importance factor values of 1 and 1.5. So 1.2 we will modify. First we'll generate this one and later on we can modify. Damping ratio is 5%. Give generate. So here see zone is 0.1. Response reduction factor 3. Importance factor we can modify here as 1.2. And then damping ratio at 0.055%. Soil type is medium. Give add. Now seismic definition is added. Next let's add the load case details. Always you have to remember in load case details you have to add seismic loads first. Before adding the dead load and live load you have to add the seismic load. EQ X. Next EQ negative X. EQ Z. Add. EQ negative Z. Add. Next we can add the gravity load which is dead load and live load. Dead load, add, and next live load. Give add. Then close. Now let's add the dead load. First we need to add the member load. So here we are having wall load as 15.3, parapet wall load as 4.5. 15.3 add and 4.5 add. So these two are added. Next we have to add the plate loads. The self weight of the slab is automatically calculated by the Staad itself since we have added the plate element. So we need to apply only floor finish load and waterproof load. That let's take it as 2. 1 plus 1 2 add. So that's all in dead load. Next let's add the live load. So go to plate load, plate pressure 4 kN per meter square for a typical floor, and for roof it is 1.5. Give add. That's all. Now we can assign all the loads. Let's go to plinth level. All the outer beams will be having the wall load, main wall load. All the outer beams will be having the main wall load. So let's select the periphery beams and then apply the main wall load. Selected. Select this load. Give us a. That's it. Next let's go to the ground floor. Go to cut section, select to view, give OK, and then select this one. So that we'll be getting the plates as well. Go to select beams parallel to X and beam parallel to Z. Here we need to deselect the inner beams. Now we can give assign to selected beams. It is assigned now. Next let's select the plate elements. All the plates has been selected. Let's assign the plate load 2 kN per meter square, and then select live load, assign to selected plates. Is assigned. Now if you see, all the loads has been assigned to these beams and plate. We can replicate now to the typical floors. Just go to this view, whole view. Just we can delete all the beams and then replicate this ground floor view. Because it will be easy. All the loads has been applied and member properties has been applied to the ground floor beam. So first let's replicate the beams. Go to Y, 4 meter, 3 steps. Do OK. See, the beam has been replicated. Next select the plate and then again give translation repeat. Y, 4 meter, number of steps 3. Give OK. So all the loads has been assigned for all floors. Now we have to assign the load for roof. Here in roof, on the periphery only parapet wall load will come. So let's assign that. Go to cut section, select to view, give OK. So we have to select all the plates and then assign the load to plates. And again live load, assign. Roof it is 1.5 kN per meter square. Only we need to assign this load. So we are done with the gravity load. Now we have to assign the seismic weight. Our main important goal is to calculate the seismic weight of the building in order to arrive the seismic load. So seismic weight of each floor is full dead load plus appropriate amount of imposed load as specified in 7.3. So here in this table, percentage of imposed load to be considered in calculation of seismic weight is given. So we are going to calculate the seismic weight at the time of earthquake. So that includes dead load as well as some percentage of live load. Up to and including 3 live load, we have to consider the percentage of 25%. And if it is above 3 means 50% of the live load we need to consider while calculating the seismic weight. So to add this seismic weight, you can go to the editor mode. Before that I have forgot one thing to add in the dead load, which is self weight of the structure. So that I need to add because all the self weight we haven't calculated. So we need to select the self weight. So we need to assign the self weight to all the beams and columns. It is assigned, and then we need to select all the plate elements and then assign to plates. See, now self weight is assigned to beams as well as plates. So now let's add the seismic weight. Go to Staad editor mode. Here already we have applied all the member load on the beams. So that we need to take. So here this member load, select everything, copy and then paste it here. So here only thing you have to remove this negative sign before the load, and then this Y direction you have to remove. So this is one load and here we have one load. Negative sign you should not use while adding the seismic weight. So this GY also you have to remove, that's all. And again you can take a copy of this and go to Staad editor mode, and here you have to enter it after this definition. So we have defined, right, zone factor, response reduction factor, importance factor, everything. So after that you have to enter these values. Member load, save, close. So if you see in this seismic definition, you will be having the member weight which we had added. This is for all the floors, and then this one is for roof. So this is added now. Next we have to add the self weight as well. Click on self weight. Self weight factor is 1. Here also you should not use the negative value. Give add. Next you have to add the element weight, that is floor load we have to apply. So for that we have to go to floor wise and then apply it. Select all the plates. See dead weight, self weight, it will calculate automatically. That floor finish and waterproof load is 2 kilonewton per meter square, that I'm adding. So this 2 kilonewton per meter square is for all the plates. It is assigned now. Next, again in element weight we have to add the live load. 50% of that we need to take, because our live load is above 3. So 50% only we need to consider. So it is 2 kilonewton per meter square only. Again I'm going to select all the typical floors, because roof live is not included in calculating the seismic weight. So only we need to consider the typical floors. Give assign to selected plates, assign. See now pressure is also assigned. All the loads have been assigned. Next let's add the load case detail. So under EQX we have to add, go to seismic load which is in X direction, factor 1, add, and in EQ negative X, factor -1, add. Click seismic load and factor is -1, add, and in EQZ seismic load, select Z direction, add, close. EQ negative Z, add, seismic load, Z direction, -1, give, add, close. So all the EQ load cases have been added. So that's all, we are done with the assigning loads. Before analyzing the structure, let's add the load combinations. Go to command, loading, edit auto load rules. So here you have to select Indian code and then select new category, create category name as load combination, and then number of rules, let's give 5. So we will be having number of rules is this one, include notational load or combination rule. So we'll be having 1 times dead load plus live load, 1.5 times dead load plus live load, 1.2 times dead load plus live load plus earthquake load, and then 1.5 times dead load plus earthquake load, and 0.9 times dead load plus 1.5 times earthquake load. So we'll be having 5 number of rules, give OK. So 5 number of rules have been added here. Now we need to uncheck whichever the load case we don't want. Roof live we are not going to add. Snow load also we are not going to add. And then let's check on the seismic load. So here you have to give the factors 1 times dead load plus live load, and 1.5, and again it is 1.5, and next factor is dead load is 1.5 and earthquake load is 1.5. Next 1.2, 1.2, and even dead load is 1.2. Earthquake load is 1.2, and last one is 0.9 dead load and 1.5 times live load. Update table, close. Now select load case details, give add, and auto load combination. Here you have to select the Indian code and select load combination category. We had given load combination, generate load. See the load combinations have been created. Now give add and close. See all the combinations have been added. If you go to the Staad editor mode, you can see clearly. See it is here. Only thing what you have to do is, here we have assigned the seismic load cases 1, -1, 1, -1, right? So negative value you have to add here. This is 1 time factor, 1 times dead load plus live load, and here it is 1.5 times dead load plus 1.5 times earthquake load. This is positive X direction, and here it is negative X direction. So you have to give the negative value here. And similarly, this is positive, and here you have to give the negative. And this one is positive, and here it is negative. This is positive, and here it is negative. And this is positive, this is negative, this is positive, this is negative. That's all. Click on save and then close. See now all the load combinations are here. Next let's go to command, analysis, perform analysis, give all, and then go to analyze. That's all. So 0 error and 0 warnings. So we are done with the analysis. Now we can check the shear force and bending moment diagram. So this is the shear force and this is the bending moment. We click the deflection, you can see the deflection. So this is how you have to model and analyze the structure. So friends, I hope you all like this video. Please do comment in the comment box if you have any queries, and don't forget to subscribe the channel for more videos. Thank you for watching.